All right, let's go through them. So I'll give you some, obviously the answers, and then any questions you can just ask them. Okay. So rotate 90 degrees clockwise about the origin. In case you weren't aware, the origin is here at 0, 0. That should be, if you don't know that, we're in trouble. Rotate A. So what we do is we get our tracing paper, put a dot here at A, draw in the triangle 90 degrees anti-clockwise, so against the clock. Should end up here, I think. You'd lift up your paper and put in the 3 points, and we have this. So that's worth 2 marks if it's done correctly. So you can start ticking as we go. Label the image C. Don't forget to do that. Take a mark off them if they didn't label it C. Only give them 1 out of 2. Reflect triangle C in the x-axis and label it D. So the x-axis is that one. So we reflect it, and it should look like it would fold perfectly over that mirror line. And this one is D. So once again, 2 marks if you've labeled it correctly and it's in the same spot. Describe fully a single transformation that's equivalent. This is a very common question to a rotation through 90 degrees clockwise followed by a reflection in the x-axis. So this was 90 degrees anti-clockwise, and so how do we get from here to here? What, anyone know what that one is? Yeah, so it's reflection and a line. So reflection, the line would be this diagonal line, and the name of that. So we're looking for the word reflection. That's for 1 mark. And then in the line, y equals negative x. So it's the negative, this one down here. This one up here is y is equal to positive x. So that's worth 2 marks, 1 for reflection, 1 for the line. Describe fully a single transformation from A onto B. So this is A onto B. It does look like a stretch with an invariant going on. Which one is the invariant? Which one is not changed? Does look like the y-axis. If you're not sure and you think it's an invariant, you could just write down the points. So the first one here is 1, 1, 2, 1, 1, 3, and the new points have gone to, oh, what's that one? That's 3, 1. This one is 6, 1, and the other one is 3, 3. So all these y points have remained, oh, you can't see that. All these y points have remained the same. 1, 1, 3, 1, 1, 3. So it's a y-axis invariant. And the scale factor, these have all been multiplied by 3. So stretch, scale factor 3, and y-axis invariant, some version of that. We need to see the word y-axis invariant and stretch scale factor 3. Okay, for 3 marks. You can give a running total if you want on that page. There was 9 marks. Question 2, more of the same. Describe a single transformation that gets from A to B. It's not going to be a reflection. It's not a translation. It's not an enlargement. So it's got to be a rotation. So rotation looks like, anyway, for 1 mark. I need more information, though. I need to know the degrees and what direction. How can I do that? Well, I can just draw in. And how do I get the center? Any ideas how I get the center? Well, I can just guess, I suppose. I'll pick 0, 0 as my center because it looks right, and it is. So 0, 0 is the center. The origin is the center of that rotation. Okay, so what did I do? I rotated 90 degrees anti-clockwise, or you could say 270 degrees clockwise if you want. And center, yes, Kalim? You lose a mark, yeah. So we need the center, we need this, and we need this. 1 mark for each. Next one, complete this statement. Triangle A can be mapped to triangle C. So A over to C over here. By translation with a vector followed by some reflection. So translation with a vector followed by some reflection. Anybody get an answer here? I know you're looking at somebody else. Does anyone think their answer is right? Or anyone want to suggest their answer? Dima? 7, 2. Okay, let's test that one. I'll just write it down here. I won't put it in yet. So translation of 7, 2. That's 7 to the right. 1, 2, 3, 4. Yep. Yeah, I know there's a bunch of ways. 1, 2, 3, 4, 5, 6, 7. 1, 2, 7, 2. So that would end up here. The person you did, I think they have this. And what did they do then? Reflection in what line? Y equals 4? I'm not sure. I think we probably want it here. That's what I would do, and then reflect in this line. So I think Dima's one is wrong. I think I'll give you my answer. Just 7, 0, I think. And then reflection in the line y is equal to 3. That's what I would do. Anybody else want theirs checked? Yes, Pauline? 3, 0. So it's here. X equals 6. No. No, that'd be over here. I can only see this one as a very simple. Okay. Okay, so that's 2 marks, 1 for each of these vectors, if they have the entire vector correct. Now you can test yours if there's any problems, maybe ask me. Yeah? Yeah, they could do that. Yeah. So they bring it down and then reflect. Yeah, that'll work. X equals 1. X equals 1. No, that'd be here. No, that one. No, it won't work. No, it has to work first. Yeah. They didn't use the word invariant. Okay. Next one. No. So that line's over here. That doesn't make sense. If there's any other ones, I'll check after because it's going to take too long with everybody. Stretch, triangle A, x-axis invariant. Okay, so what I do for this is I just write all the points. 1, 1, 2, 1, and 1, 3 are the 3 points. X-axis invariant, so they're going to move to, x is going to stay the same. 1, 2, 1, and the y-axis gets stretched to 2, 2, 6. And then we put in these new points. 1, 2, 2, 2, and 1, 6. And that's how we do that. So it should look like that. Okay, so if it looks like that, yeah, give them 2 marks for that one. And then we move on to question 3. Okay. Describe fully a transformation that maps A onto B. So we got a reflection. What's the line of reflection? I think it's this one. That's 2 boxes. That's 2 boxes. Which is x is equal to -1. All right, you with us, Mary? Thank you. Yes, so reflection for 1 mark, and then another mark if they get the mirror line correct. Rotate B through 90 degrees and draw. So once again, I need my transparent paper. 90 degrees, clockwise, center -1, 6. -1, 6 is here. Clockwise, 90 degrees, okay. Okay, so B should be down here at -1, 4 is that top coordinate. And label it C. So we need the label C as well for a mark. So if they didn't label it C, take a mark off them. Describe fully a transformation that maps C onto A. So C needs to go to A. Anyone have an idea here?
X plus y equals x plus 7.
Y is equal to x plus 7. Right. We have to have there's a line here, isn't there?
X plus 7.
Yeah, so it's a reflection.
Is that
1 mark for reflection, then you got to get the line right, which is the other mark, which is a difficult mark, yes.
The person who does the best, the people who do the best.
Yeah, you get my eternal congratulations and my respect.
So we don't get a percentage.
No, I get nothing. No. Tough luck. Okay. Reflection, what's the line and how do we find it? Okay, to find the equation of a line, we need to know where it crosses the y-axis. This one crosses at 7. And we need to know the gradient. So for every rise of a run, the rise of this one is, well, 1 over 1. So all along it, it's 1 over 1. Or you can do 2 over 2. So the gradient is just 1. So that's y is equal to 1x, or just x plus 7. So very good if you got that. That was probably difficult. Okay, let's translate this vector minus 4, 2. So that's, by a vector, minus 4, 2. Do each point, so that's 4 left, 2 up, 1, 2, 3, 4, 2 up here. So that one moves to here, one's here, one's here, and we have this shape somewhere up there. Okay, describe fully a single transformation that's equivalent to translating by a vector minus 4, 2, followed by a rotation of 90 degrees. So I got to do this second thing. Minus 2, 6 is up here. 90 degrees clockwise. All right, my page is getting full of triangles. 90 degrees clockwise, that's the way the clock goes. Ends up here. Okay, so that's where it ends up. And how do I get from here to here? It looks like is it a rotation?
Yeah.
Where's the center, you think? Let's have a look to see if it is a rotation. Let's get a clean piece of paper.
Century.
7 1?
1, 7, 1.
Well, you say 1 7. Okay, that looks like it's right. If you weren't sure, you just try random points. So if I picked here at 4 0, us doesn't make it. So it needs to be a bit higher. I picked 6. Oh, that's pretty close, but it needs to move a bit over. You're saying 1 7, and it is 1 7. So it's a rotation. Which direction was that? That was clockwise. That was 90 degrees. And the center, you just said 1 7. 5 marks for that. Okay, that's tricky. 5 whole marks. Which you don't write down which bit? I'm going to say 1 mark, 1 mark, 1 mark, 2 marks for the center. Yeah? $270 anti-clockwise. 270 anti-clockwise. Okay, and the last question. You need to write rotation. Oh, I've never. Oh, amazing. Thanks. Okay, find the coordinates of the image 4, 1 under transformation P. Okay. 4, 1 is here. P is a rotation clockwise about the origin. It's not a shape, but we can still rotate it clockwise about the origin. Where do we need to go? 90 degrees clockwise. 90 degrees clockwise. Clockwise. Clock goes this way. We end up down here. What's the new point? Well, that's 1 minus 4. Find the coordinates of the image of 4, 1 in this line. Y is equal to negative x. That's that line. So this one's going to end up over here somewhere, isn't it? There. That's at minus 1 minus 4. Find the coordinates under transformation P followed by transformation Q. So we can use this point. Does it end up here? So if I do P first, it ends up here, and then I reflect it in that line, it ends up there. I'm just using this point. So if it was 4, 1, it would become 4 minus 1. So if it was x, y, it becomes x minus y. A single transformation that would do that is a reflection. So it just is a straight up reflection in the x-axis. Reflection, I'll accept in x-axis, but the proper line is y is equal to 0, or I'll accept x-axis. Okay, tot up their marks and give them a total. I don't know what it's out of, I forgot.
37.
And you can give them percentage then if you want.